So find the zeros of the function, draw a rough sketch of the graph, write the polynomial function in standard form, classify the polynomial. The test is next week, before Thanksgiving break. So we got like 2 more lessons after this. This is going to be chapter 4 and 5. For chapter 5, only like 2 sections. All right, find the zeros for the function. So we set it equal to 0. So what's the first zero? What's the first zero of the function? Anybody, what's the first zero of the function?
5.
X equal to 5. You be your own judge. If you're sitting around just looking at and don't know what we're doing, we did this a lot already before. What's the next zero of the function? X equal to what?
2.
If I plug in X is 2, 2 take away 2 is 0. 0 times anything is 0. The whole thing is 0, which is equal to 0. X equal to 2. And the third zero of the function is going to be what? X equal negative 2. If you plug in X equal negative 2 here, negative 2 plus 2 is 0. 0 times anything is 0, equal to 0. So we found the zeros of the function. We're going to draw a rough sketch of the graph. What's the degree of this function? Anybody, what's the degree of the function?
3.
It's a third degree polynomial. Why? Because it's a single root, single root, single root. So the power of this is 1, 1, 1, and so power of 3. So what do third degree polynomials look like? I call it a sideways S. Some people say it doesn't. It looks more like an N. Something like this. Okay? So that's what we're looking for. So that's what we're going to draw. I should have already done it. All right. So let me draw it over here. So we got a 0 at x equal negative 2. We got another 0 at x equal to 2. Another 0 at x equal to 5. And we're going to draw a sideways S looking thing, or more like something that looks like an N. Let's wait a second before we draw it. I could already draw it and go like this and like this and like this. But let's continue on before we draw a rough sketch of the graph. Let's write the polynomial function in standard form. All right, so how do we write it in standard form? Let's get the function again. What does it mean to write it in standard form? Multiply it out. Multiply it out. Yes. So what we're going to do is multiply this out. It wouldn't be a good idea to multiply the first 2 factors. These 2 factors would be a good idea because there's something about them that's going to make it easy. X times x, x squared. X times 2 is 2x. Negative 2x. I'll put it here. And negative 2 times 2 is negative 4. So let me just hold down to that, and let's put the x minus 5 here. So in this, what's going to happen right there in the middle? What's going to happen right there in the middle? It's going to cancel out. So then I'm going to have x squared minus 4. Then what? What now? Am I done, or what am I supposed to do now? Continue on multiplying it out, no? So now I'm going to multiply this out. X times x squared. What's x times x squared? X cubed. I'm going to put this one first. Look, I am going to do this one, but I know this one got to go first. I'm going to multiply this out. That's going to be negative 5x squared, so it's in order already. And then I put the negative 4x. and then the positive 20. So it is a third degree polynomial. What is the y-intercept of this polynomial? Isn't the y-intercept this right here, 20? So y-intercept would be somewhere right here. I could make it go 5, let's say 5, 10, 15, 20. It's like right here. Let's say that I do it like that. Then maybe you can get a better idea of what exactly maybe the graph would look like. So it's going to go something like this. And I don't know if it's going to turn there. Maybe, maybe not. I don't know. But definitely it's going to go through there. It's going to go down through there. And then it's going to, I don't know how low it goes. Then it goes through 5. And then that's as best as I can do without a graphing calculator. It is a third degree polynomial. All right, so I'm gonna, let me see if I can remember this. I can, x minus 5. All right, let me put this in decimals. Just, why not? If I have this, why not? Y equals what the heck was it? X minus what? Minus 5? And then was it is minus 5 and then x what? No, isn't it x plus 2? Oh well, I'll put it later. X plus 2 because it's x plus 2 and then x minus 2. Oh man. Let's take a look at this. Wow. Man, I was off by a little bit. But it went through 20. Man, I'm good. Is this sideways S? Or does it look like an N? Oh no, it doesn't. Well, it looks like an N, maybe. Better. And it goes through negative 2, 2, 5. All right. Let's continue. All right. The fundamental theorem of algebra. This is the last section for chapter 4. What are complex conjugate zeros? Complex conjugate zeros is that imaginary solutions come in pairs. So complex conjugate zeros. Complex solutions always come in pairs. So you have a function that is a polynomial. So I don't know if in your own experience you have a family function. And in your family function, which is your birthday or something like that, I don't know what, something, a family function, and you see your uncle. Your uncle is, he comes through the door of your house. And if you know that your uncle is there, you know like who's also going to be there. Who? Who's going to be there? Your aunt. Why? Because she would never let him go by himself to a party. So complex solutions always come in pairs. It never by itself, always in pairs. So write the polynomial function in standard form. So you got this, these are complex solutions right here for this function. Let's go ahead and multiply it out so we can write it in standard form. All right, let's do it. F of x is going to equal 2. X times X
plus 2i
plus 2ix minus 2ix
plus 4i
is minus negative 2 times positive 2 is minus 4i squared. What's going to happen right there in the middle? It's going to cancel out. And what is I squared equal to? Negative 1. What's negative 1 times negative 4? Positive 4? Yes? Positive 4. And I'll bring this down. So there's the function in standard form. F of x equals x squared plus 4.
Wait, I squared equals what?
Negative 1. Negative 1 times negative 4 is positive 4. Negative 1 times negative 4 is positive 4. All right. Next. We're almost done here. So it's going to be a quick lesson. All right, your turn. Let's go. We'll give you like 3 minutes to finish. Maybe I wasn't too clear on. Let me stop you on what conjugates are. Hey, here, everybody, look. If I told you x plus I is a solution, what must also be a solution? That's called conjugates. If I told you x minus 3i is a solution, what also is a solution? X plus 3i. I think you get it now. If I told you x plus 4i, I don't know. You get it now. What is it? X minus 4i is a solution. So that's like, yeah, your uncle, your aunt, your uncle, your aunt, your uncle, your aunt. All right, yeah. All right, let's go. Continue. Does anybody have a problem with what I just said and people are working it out? What did I just say about complex solutions? Or don't complex solutions come in pairs? Yes or no? Isn't this contradictory to what I just said? This is okay, but isn't this a complex solution? What must also be there if this is your uncle? So nobody asked. I was waiting for somebody to bring. Hey, where's the aunt at? Just keep going. Work it out. Multiply this out. Look, multiply the second and third, and then multiply by this. Let's go. What's going to happen in the middle of that one right there? You guys doing? Cancel out. And then it's going to be x squared. And then this is going to be what? What is this? Negative 1 and negative is a positive 1. I'm going to do this one first. Again, minus 5x squared. Then that's going to be plus x. Then minus 5. Third degree polynomial. One real solution, two imaginary solutions. Oops, it didn't have any answer. All right. I went too fast? I don't know. All right, let's move on because we got to finish this already. Problem number 3, last problem. Write a polynomial function of minimum degree in standard form with real coefficients whose 0 include 4 and 2i. 2 minus I. How many real solutions does this one have? How many real solutions does it have? How many real solutions does it have? Only one. Real solutions don't come in pairs. Complex come in pairs. So x equal to 4 is a solution. How many complex solutions does it have? 2. So x equals 2 minus I. And also x equals what? 2 plus I. 2 plus I. All we got to do is move them back as factors and we're done. So it's going to be what? Do I need to write it down? Can you just do it in your head or what? I got it right down. Minus 4 to both sides. Cancel is x minus 4. Yes? This one's going to be what? Well, let's write it down. So this one's going to be what? Minus 2 and then what else? Plus I. So really that's what you need to write down. X minus 2 plus I. And for this one it's going to be what? Minus 2 and what? Minus I. So it's going to be x minus 2 minus I. And then just set it equal to f of x and we're done. That is the lesson for today. That is it.